Welcome to Ask and Learn.
Hey, it's Clarissa. So we have two parts to the solution. The first part, we're given that C is bigger than B, which is bigger than 1, and we're doing a proof. So the first part, f of n is equal to b to the n, and g of n is equal to c to the n. So just for convenience, let k equals 1. So for n to be bigger than k, we're going to obtain using b is bigger than 1. So the absolute value of b to the n power is equal to b to the n. And since c is bigger than b, this is less than c to the n, and c is bigger than 1, this is absolute value c to the n. So c has to be at least 1. So let's make c equals 1. And by the definition of the big omega notation, b to the n is O of c to the n with constants k equals 1 and c equals 1 as well. For the second part, we have f of n is equal to c to the n, and g of n is equal to b to the n. So let's assume that f of n is equal to c to the n is O of b to the n. So there exist constants such that the absolute value of c to the n is less than or equal to big C absolute value of b to the n whenever n is bigger than k. So let's choose k to be positive. So since c is bigger than 1 and b is bigger than 1, we know that the absolute value of c to the n is equal to c to the n, and the absolute value of n to the d is equal to b to the n. So c to the n is bigger or equal to big C times b to the n, and since b is bigger than 0, then we know that b to the n is bigger than 0 as well. So let's divide each side by b to the n. So c to the n divided by b to the n is less than or equal to big C. So we can rewrite this inequality as c over b to the n is less than or equal to big C. And since c is bigger than b, the base c over b is bigger than 1. So we have a contradiction because the function c over b to the n is unbounded when n is large. So there can't exist a constant c such that where c over b to the n is less than or equal to constant c when n is large. So we obtained a contradiction, so our assumption that f of n is equal to c to the n is O of b to the n is false. So f of n is equal to c to the n is not O of b to the n. So b to the n is O of c to the n, and c to the n is not O of b to the n.